There it goes. Okay. Again, you should have your notes for dial calipers uploaded in the last assignment. And there wasn't a lot there, just a few labeling mainly. And then the measuring we'll do here. Seems a little out of focus. Press that. So before I go to measuring out this little Lego, let me start off with my ring. So we can kind of practice. Maybe I should zoom in a little too. Practice getting the numbers down. Let's see. That's probably a little more. There we go. Okay. So this is my wedding ring. I can measure the outside of it by putting it in between the jaws here. But before I do that, again, the main components here, you've got this piece that can slide back and forth. I can move it back and forth with my thumb. It rides on this rack gear, right? And it's a very common precision tool. The first thing you should do when you get it is you close it, put a little pressure and make sure it's on 0. If it's not on 0, then the gear's got a little misaligned, but it's good right now. So I'll open it up and I'm just gonna put enough pressure to where it holds it. Like I don't need to try and crush it or anything like that. So like with a plastic part, that would be more possible, or a wooden part. This ring is actually a really hard metal, but just enough to kind of hold it in place. And if I look at the numbers, I'm getting a number from here, and then I'm gonna get a number from here. 2 numbers from the dial, actually. So my first number here I see is 9. And then I look over here and I see that on the dial, like here's 10, right? It goes all the way up to 99 before coming back to 0. So this is actually sitting on 4. What that would be as a measurement would be 0.9 for the first number. 0.904. That's the amount of inches it is. 0.9 is like 9/10 of an inch. So it's just 4/1000 of an inch over 9/10 of an inch, or 0.904 inches. And usually what we've been doing with inches is fractions, so it's a little bit different. To get the inside measurement of the ring, which is the more important measurement, because that's where the finger goes, so that's the sizing that you need to know. The inside measurement, I use the back part up here. You've got the outside measuring faces here and inside measuring faces here. Again, I'm just gonna open it up until it holds it, but I'm not trying to like stretch it or anything. So I don't need to put a lot of pressure. And then I'll look at my values here. I see a 7 there in my list. And then over here, looks like 15. So there's the 10 and the 20, it's right in the middle. So 7/15. For perspective, I guess 3/4 of an inch is 750. So this is close to 3/4 of an inch. Then I'll measure the height, how tall or how wide or tall, I don't know, tall it is. So then I've got 3, 15 again, so 0.315. So it's really easy to read this thing. There are a few issues that we'll see as we practice that you'll also have to consider, but you can see how simple it is. And it can really measure extremely small things. Like here, I'll measure one of my hairs. Oh, there we go, got one. It might be hard to see on the camera. Hopefully you can kind of see that in between my fingers, I have a little hair. Here it is at 0. I'll open it and close it. And there, my hair is 0.002. There's no thickness to it, 0.002 inches. That's pretty thin. That's 2/1000 of an inch. And that's not even the smallest it can measure. It could measure 0.001. My beard is actually a thicker hair. Let's see if I can get any beard hair loose in it. Maybe not. I pulled all the loose ones out this morning. Well, I can grab my beard hair easier than I could grab my head hair. So let's just measure it here. Oh, that doesn't really work, does it? No, I just look ridiculous. But it's 0.003 is what I was able to measure. 0.003. So it's a little bit thicker. Not as thick as my head hair. I mean, it's thicker than my head hair, a little bit thicker. Oh well. Put up a comb. I should have just taken out a comb. Oh, we could look at that. Brushes. Even thicker than my head hair. Like, how thick is that bristle? Look at that. It's 0.010. So it's like 5 times thicker than my head hair. Interesting to think about how thin things are. A piece of paper is about 0.002 also, I think. Yeah, it's about the thick. Actually, it's a little bit thicker than my hair. And you can actually measure different people around the classroom and get different hair thicknesses. It's kind of interesting. All right, let's go to the Lego. Let's get these measurements. This is the main one. I actually want us to be able to reproduce this Lego on a computer with a computer-aided design program when we go online, if that all works out. So I do want us to have the numbers down for later, but that's probably something we'll do in January because we're at Thanksgiving now. When we come back, I know we got to test over this material and we're going to have that project. We'll do that first, the Catapult project. So when we get back, then we'll start doing some CAD stuff. So this might be one of the things this is most likely to be one of the things we'll do. So let me measure the little peg up here on the top. Ah, good. This is one that I wanted to show you. So from what I've shown you so far, you would say 0.288, right? But look at the arrow. The arrow is on the left side of the 0. If it were 0.2, it would have to be over here. So, and if we measure all these, they're all going to be very close to each other. So that one's at 0.9 or at 90. 90, maybe 90 is the average. 89. So this is actually not 0.2 because it's less than the 0. It'd be like when you look at the clock and the hour hand is at 2, but then you look at the minute hand and it's like says 58. That means it's not 258, it's 158. It's very close to 2. Same thing here. It's almost 0.2. It's at 0.189. So it's super close, almost 2. So 189. 0.189. All right, let's get the cross. You know, way early. With the cross here is, we got a 6 there, and then what can you read on the dial? 23. So 623, 0.623. Let me show you a new one I haven't showed you is the back of this thing. See how it's kind of dark? There's a flat surface here and a flat surface here that at the beginning, they're right up against each other. So I can actually use that to measure the distance. It's called a step measure. measure the distance between the end of these pegs and the flat surface here. So I can just, let me see if I can show it from the side. I've got it pushed up against the pegs, and then I'm gonna bring it until it touches there. And then I can read the distance there. So it's, the first number is a 0, so it's 0.0, and then what do I have on the dial? Yeah, 59. It's almost at 60. It's the one before 60, so that's 59. So 0, 59. Now what we could do is we could measure from all the directions and get like an average or something. But I want to make sure that we have time to finish. Then another measurement I would need is how tall this is. All right. And then how tall the pegs are. But I can't like measure how tall the pegs are with the dial calipers because I can't put it on any surface. But what I could do is I could measure the size of the box and then the total size. And if I wanted to get just the size of the pegs, I could just subtract the two. So let's get the size of the box here. What measurement do you get for that?
$78.
Okay, so we got 78. That's the second two numbers. What's the first number?
3.
Yeah, you're correct. It's 3. We're not quite at 4 yet. We can see 4, but it's not there yet. So 378. Good job. All right. Now this next one, I'll measure here. Write down what you think the answer is. I'll try to hold it still. I know it's not the best shots. But go back to Canvas, click on attendance check-in, and when you do your attendance check-in again, because the second time today, I'll do like a participation grade. At the bottom where it says, you know, do you have any questions for me? Just put your answer. So you can put your name and period, and then put assignmenting, and then put what your measurement was. So I'll try to hold it still right here. And then as you submit them, I'll give the answer in a minute. And then you can see if you got it right. I won't call anybody out or anything.
Is it
I'm not going to say
4?
yet. So far, I've only gotten 3 answers, and all 3 of them. Oh, someone just changed theirs. I wonder how you can do that. I was going to say all 3 of them were different. They ended the same, but they had one number that was different between them. So. I guess if you resubmit it soon after you submit it, it will correct it or something. That's interesting. But I only got 5 of you guys paying attention today. Where's everyone at? Submit your answer. All right, so if you're sending it, just send it right now. The answer is 446, it looks like to me, because here's the 5. 446 inches. Only one of you thought about putting inches. The rest of you just sent a number. So don't forget that you got to put units too. That's very important. So 0.446 and then inches. You could put the little kind of like quotes for inches, or you could just put IN, of course, for inches. It means the same thing. So that's our answer. Oh, you got the 46 right. Just one of you. It's the beginning, the first one. Yeah. It happens. You can see the 5, but it's not 5 yet when it's closed. You can see it, but it's not 5 yet. All right, now we've got the bottom. So the reason why I drew these faces, because these are the only different faces. You have the top and the bottom is how it's connected. Those are obviously very different. But then the front and the right and the back and the left, they all look the same. So you only need one of those drawings. So the Lego, you would only just need those 3 to really kind of describe it for someone to make. So when I look at the bottom of it, this is the part that holds the top pegs of the next one, of course. This one's off brand, by the way. It's Tyco. I've had it since I was a kid. It's all mixed in with my regular real Legos. But you've got this outer edge here. And then you've got this center peg that has a hollow part. I think I have some. I found another, this one that says Lego on it. So this one's actually the name brand. On the bottom, it's actually different. You can see the circles are a different thickness. It's got like this bar across here too. And if you look down there, the little like small openings down there, these are much more precise looking. These have very rounded edges. So, and this is a thinner wall here with little ribs. So they're probably making this outer wall a little bit thinner to save on material, but putting the ribs there to have the same type of support. So it's kind of interesting. Lego really is a high quality brand. That's part of the reason why they're expensive. They've been around for a while and they have a lot of attraction, but it's actually really high quality engineering has gone into manufacturing these things so that you could click one from the 70s from today's Lego and they would fit. They've all been the same size always. So let's get these measurements. So I'll get the thickness of the wall here. So that's with this piece. And what measurement do I have there? 0.60, 0.061, good, yeah. Don't forget that 0.061 inches. Yeah, it's, with it closed, you can't see the 1 there. That means it's under 1/10 of an inch. With this center peg there, I'm going to measure it 3 different ways. We've got the outer diameter, the inside diameter, and then kind of like the depth going in. And that's going to take 3 different features on here to measure. So the inner diameter, DI for inner, that's going to be this top part. So it's not a very big circle, so I got to get it in there just right. Again, I don't want to be putting so much pressure that I'm actually deforming the plastic in there. So just enough to kind of hold it in place. And what number do we have there? 0.1, good. Yeah, we see the 2, but it's not past 0 yet. So 0.1. Yeah, it looks like it. It looks closer to the 82. I agree with you. 0.182. All right, then outer diameter. That would be with these main jaws right here, the outside measuring faces. Got to try to get it in there as diagonally, I think. Okay. Oh, no, yeah, wrong. There we go. All right, so definitely 0.2 again. You know, this is really close to 1/4 of an inch. 1/4 of an inch is 0.25. So this is 0.2, and look how close it is to the 5 part. Gosh, it's a little blurry. This is like a really high quality camera that Zoom is like downgrading. I don't know. think it's closer to the 8. It is kind of pixelated looking. But yeah, looking at it here, it looks closer to the 48. So 248. If I give this to you on a test, it'll be a much better picture. It's a really high quality camera though. It's just Zoom is really downgrading it to ship it to everyone, so to speak. All right, so at the back of the thing, this little rod comes out. This is for measuring depth. Some dial calipers, this one's like a machined rod here. Other ones are like an actual like cylinder rod. So the way that I measure with this, if I'm going to get a depth, is I extend it out more than I need. I line it up to the bottom, and then I bring it down to the edge. And I want to make sure I don't get it inside of those little recesses there. But this is the measurement for the depth. Got, what do you got there? 0.3 what? 37? 30? 36, yeah. 36. There we go. Usually in class, I would just pass these out and I would give you some things to measure, but that wouldn't work. I wish you could use them, because then it's a little bit different when you can feel it yourself and hold it. They're actually, I mean, they're all machined metal and stuff like that, but like if you drop them, you can break them. I actually broke the first one on accident. When showing it, I was like, this is a dial caliper, and I threw it. Like an idiot. Anyways, so there's all our measurements. So this was an easy assignment. Just take a quick shot of that and upload it. And that is it for today. If you've uploaded both of those drawings,